So, good morning, students. So, we will continue our discussion on straight lines. So, today what we are going to discuss about the equation of a straight line in intercept form. Okay. So, if you let me first show you the particular topic in front of you. But before I continue, please can you please confirm that you are able to hear my voice very clearly and able to view the screen properly?
Yes.
Okay, great. So, what is intercept form? You know, if you recall in the previous few sessions, since we started discussing about straight lines, I informed to find the equation of a straight line, two information has to be given to you. And whatever we have seen so far, we have seen, slope intercept from where slope is given and intercept on the y-axis is given. Then we have seen it is a, point slope form. That means a straight line passing through a fixed point and having a, fixed slope. Then we can find the equation of that straight line. Then we have seen that, 2 points form means a straight line passing through two given points. So in all these cases, whatever you have seen, dear students, that you have seen that there are two information given to you. In this case also, intercept form, there are also two information given to us. What are the two information? Intercept. Intercept says that what is the straight line mixed with the x-intercept and y-intercept. Okay. So for example, if I draw the coordinate axis first, this is, that x-axis, this is y-axis. And suppose we have a straight line, something like this, what I, drawn in the blue color, that is our straight line. Now this straight line makes an intercept in the x-axis. So what is the intercept in the x-axis the straight line is making? Suppose A is the intercept makes on the x-axis and B is the intercept makes in the y-axis. So that means we also get two informations here, dear students. Suppose the straight line intersect the x-axis at the point A. Other way, what we can say is that coordinate of the point A is lowercase a comma 0. And if the same straight line intersect the y-axis at the point B, then we can say that as the y-intercept is B, other way we can say the coordinate of the point, okay, B, which is the intersection of the y-axis and the straight line, is 0, B. Correct? Now, dear students, if you need to find the equation of a straight line passing through the 2 points a, 0 and 0, B, we can use the information what we have learned in the last class, that is the 2-point form. What is the 2-point form? 2-point form says that equation of a straight line in the passing through a, 0 and 0, B is what? Y minus y1, y minus 0 divided by y2 minus y1, that is b minus 0, that is x minus x1, that means x minus a, divided by x2 minus x1, that is 0 minus a. So what we are getting, dear students, here? Here we are getting minus ay is equal to bx minus ab. So from here what we get? That bx plus ay is equal to ab. Correct, na? So now if we divide both sides by ab, then what we get? Bx by ab, that is equal to so what we get is that bx by ab is nothing but x by a plus ay by ab is nothing but y by b, that is equal to 1. Since A into B is not equal to 0. So this is the equation of a straight line in intercept form. Okay. So what is the required equation here, dear students? The required equation here is that, so if I can write is the required equation with x-intercept A and y-intercept B is something like this. Okay. The equation of a straight line making intercept A and B on x-axis and y-axis respectively is something like this. Okay. Now there are few cases that we need to discuss. That first case is that something like that the sign actually important, A and B. A and B, what I wrote here is a symbolic representation, but you do not know exactly what is the sign of A and B. So let us see by means of some practical example. Okay. So, and if you recall our previous classes, on slope intercept form, so there are two parameters. One was the slope, that is m, and another one is that y-intercept, that is c. Now we have seen that if we vary that m and c with respect to positive or negative, then how the straight line actually looks like. Means when you did m greater than 0, c greater than 0, the way the straight line will look like, it is different than when x greater than 0, m greater than 0, but c is less than 0. Then c greater than 0, m less than 0. Then both m and c less than 0. Like that. Here also, here both a and b are there. So we can have a greater than 0, b greater than 0, a greater than 0, b less than 0, b greater than 0, a less than 0, and a less than 0, b less than 0. We'll see all these cases. But before that, I would like to tell you one thing, dear students, is that this equation that x by a plus y by b equal to 1, that also we can write in the general form. Okay. So what is the general form of an equation of a straight line? You know that ax plus by plus c equal to 0. Now, if you recall that ax plus by plus c is equal to 0 is the general equation of a straight line, right? That's what you know. And we will see that whatever we get, x by a plus y by b is equal to 1, we can also express in this form. So how we can write is then, so this is equal to, we can write is that bx plus ay minus ab is equal to 0. And this is in the form of ax plus by plus c is equal to 0. Dear students, do not mix with that whatever I wrote ax plus by plus c equal to 0 here, and that a, b are different. It is just an analogy, that is that to make sure that is in the form of ax plus by plus c. So if we make a comparison with this equation with ax plus bx plus ax plus by plus c is equal to 0, then what becomes c? C becomes minus ab, b becomes a, and a becomes b. I just wanted to show you that, okay, how it looks like. Okay, anyway, let's come back to our discussion that, as I was telling, that based on the values of a and b, we will see that how the straight line actually getting different. The first case, what we are seeing is that, dear students, is that let's take a greater than 0 and b greater than 0. That means what? That is the case 1. That means in this case, both x-intercept and y-intercept are positive. So how the straight line will looks like? If this is the coordinate axis, that is x and that is y, this is x dash, this is y dash, and this is origin. And if you draw a straight line something in green color, so if you see both x-intercept and y-intercept are positive, correct? No? So this is a and this is b. So what we see is that a greater than 0, b greater than 0. One such example is that we can write that x by 2 plus y by 3 is equal to 1, where x-intercept is 2 units and y-intercept is 3 units. And we can find the equation of the straight line as x by 2 plus y by 3 is equal to 1. So this is case 1. Now let's look into the case 2. What is case 2? In case 2, what we see is that A is greater than 0, but B is less than 0. Dear students, so how the configuration looks like? Let me first draw the coordinate axis. Okay. Now here A is greater than 0, but B is less than 0. So the straight line, if I draw in blue color, it will be something like this. You see, the x-intercept A, that is greater than 0, but y-intercept B, that is less than 0. Why it is less than 0? Because it is below the x-axis, negative side of the y-axis. So in this case, what we see, dear students, that A is greater than 0, but B is less than 0. So what will be a sample equation of such kind of straight line? X by 2 minus y by 3 is equal to 1. You see the y-intercept is negative. Minus y by 3 means what? Plus y by minus 3. Correct? So this is the second case. Now the third case is that when A is less than 0 but B is greater than 0. Let's see how it looks like. So here the case 3 is, A is less than 0 but B is greater than 0. Now let's draw the coordinate axis first. That is origin. Now let me use a different color. So here A is less than 0 but B is greater than 0. A straight line will look like something like this. You see, dear students, here A is less than 0 because left hand side of the x-axis, that is why less than 0. But B is greater than 0 because it is in the above the x-axis, that is the positive side of the y-axis. So what you see here, dear students, here A is less than 0 and B is greater than 0. What will be one representative example of an equation of a straight line, where A is less than 0, B is greater than 0? That means could be minus x by 2 plus y by 3 is equal to 1. Or we can write this thing. We generally do not prefer to start with negative. So we can write is that x by 2 minus y by 3 is equal to minus 1. That is one representative example. So whenever you get this type of equation, you can visualize in your mind that exactly what type of straight line is actually looks like. This type of visualization sometimes helps you to solve problem in relatively, simpler manner. Okay. Now let's look into the fourth case. The fourth case is that when both are negative, A is less than 0 and B is less than 0. Okay. So now we are going to discuss about the case 4. Okay, here A is less than 0 and B is also less than 0. So let's see how it looks like, dear students. So this is the coordinate axis, x, o, x dash, x dash, and y, o, y dash. And when A is less than 0 and B is less than 0, the straight line looks like something like this. I'm so sorry, I made a mistake here. A less than 0, B less than 0 will be something looks like this. Why looks like this? Because A is less than 0, negative side of the x-axis, left hand side of x-axis, that is the negative side of x-axis. And B is also less than 0 because it is below the x-axis, that is the negative side of the y-axis. So here what we get, dear students, A is less than 0, B is less than 0. So what will be one sample representative equation? So that should be, suppose minus x by 2 minus y by 3 is equal to 1. Or as we do not prefer to write negative, start with negative in any expression or equation, so we can write something like this. This means x by 2 plus y by 3 is equal to minus 1. So these are the 4 possible cases, okay, based on the the values of a and b are either positive or negative. Now, dear students, what we are going to do, we are going to solve some representative questions. We will solve some questions. So what I'll suggest you is that you also open your notebook and do along with me. The first question, what I'm going to place in front of you, it will be available in another few seconds. Okay, dear students, so this is the first question. This question says that, sorry, the question says that find the equation of the line which cuts off an intercept 4 on the positive direction of x-axis and an intercept of 3 on the negative direction of y-axis. Very classical question. Actually, this falls into the category of where A is positive and B is negative. What is A here, dear students? A is equal to 4 because positive side of the x-axis greater than 0, and B is equal to minus 3, that is less than 0. So our equation will be what? X by A plus Y by B is equal to 1. That is the equation, right, in the intercept form. X by A plus Y by B is equal to 1. That implies what? Now let's apply the value. So that implies x by 4 minus y by 3 is equal to 1. We can simplify it further because 4 and 3, their LCM is 12. So we can write 3x minus 4y is equal to 12. Or we can say is that 3x minus 4y minus 12 is equal to 0, which is in the form of general equation of a straight line, ax plus by plus c is equal to 0. So this is the required equation of the straight line, okay, which makes an intercept 4 on the positive direction of x-axis and 3 on the negative direction of y-axis. But how that straight line will looks like? Though we have discussed few minutes back, but I want to show you that how it will looks like. X, y, x dash, y dash. And if you see, dear students, this is the origin. So x is positive and y is negative. So let me place the origin somewhere here so that it will be helpful as to draw the diagram properly. So x intercept is 4. So suppose this is 4, 4, 0. Other way we can say is that this point A having coordinate 4, 0 and this point having coordinate, point is B, coordinate 0, minus 3. Now if I draw the straight line in a different color than red, suppose if I draw in blue color, so the straight line which looks like something like this. That is the equation of the straight line. What we can either write as x by 4 minus y by 3 equal to 1, or we can write this is equal to 3x minus 4y minus 12 equal to 0. I hope it is very clear, dear students, that how to find the equation of this straight line. Now, dear students, let's come to the second question. The second question is that let me make the question available to you in another few seconds. Okay, here the question is, find the equations of the straight lines which passes through the origin and trisect the intercept of the line 3x plus 4y is equal to 12 between the axes. Okay, very good question. So let's first make a visual representation of this question before we proceed further. So let's first draw the coordinate axis, because to draw any straight line or curve in any in two-dimensional or three-dimensional, first you need to draw the respective coordinate system. Here it is a Cartesian coordinate system. That's why we are having two mutually perpendicular lines as x-axis and y-axis respectively. Now, if you look into the first straight line is that 3x plus 4y is equal to 12. Okay, if we represent this in the intercept form, so how it looks like, dear students? 3x plus 4y is equal to 12. Whenever you get this type of equation, better to make it in this form: x by 3x by 12, that means x by 4, plus 4y by 12, that means y by 3 is equal to 1. So this representation, that x by 4 plus y by 3 is equal to 1, gives a visual representation in your mind, as if like that x-intercept is 4, 0. Correct, no, dear students? That is 4, 0, A. And y-intercept is 0, 3. So this is the point B, 0, 3. So the equation of this straight line, if I draw it in the green color, so that equation of this straight line is visual representation is something like this. But that is not the question. That is not the equation of the straight line we need to find. We need to find different straight lines, dear students. So now let's go back to the questions one more. Find the equations. Here it is a plural number. Okay, find the equations of the straight lines which passes through the origin and trisect the intercept of the line 3x plus 4y is equal to 12 between the x-axis. What does it mean? That line segment AB, this has been trisected. That means we can find 2 points. Suppose this is the point C and this is the point D. So if we consider this is the point C and this is the point D, okay, that means BC is equal to CD is equal to DA. Okay, so this is the point D. BC is equal to CD is equal to DA. That means that that line segment AB is trisected, because these are the three equal length of this straight line segment AB, that is BC one part, CD one part, and AD one part. Okay, correct or not? So now what you need to find the equation of the straight line. And equation of the straight line, again, if we revisit the statement of the question, find the equations of the straight line which passes to the origin. So first it will pass to the origin, and second one is that, and it passes to the origin and trisect the intercept of the lines 3x plus 4y equal to 12 between the axes. That means one straight line is something like this. This is one straight line, and another straight line is something like this. Correct? This is another straight line. Suppose if we give this straight line as L1, and suppose this you give as L1 and L2, so this is L1 and this is L2. Now, how to find that one? So, to find that one, we need to find the coordinate of the point C and D. Correct or not, dear students? We need to find the coordinate of the point C and D first. Then only we can find the equation of the straight line passing through the origin and the point C, and passing through the origin and the point D. Now, how we can find the coordinate of the point C and D? Okay, so to find the coordinate of the point C and D, we need to get back to our concepts of loading of that internal section formula. Okay, so if you see the section formula, so how the problem we can represent something like this. So always make a representation of the problem clear. So this is your point B, or you can say this is the point A with coordinate A, 0. This is the point B with coordinate 0, okay, not A, 0 actually per se. It is already given, it is a 4, 0. So coordinate of the point A is 4, 0. Coordinate of the point B is 0, 3. And you have 2 points in between. Okay. So this point is C and this point is D. Let us first find what is the coordinate of the point D. As we see that what is the AD is to a DB. So if we assume that each length is 1 unit, that means AD is 1 unit, DC is 1 unit, DB is 1 unit. So as if that it is divided in the ratio of 1:2, correct or not? AD is to DB. What we can say, AD is to DB is equal to 1:2, correct or not? So AD is 1 and DB is equal to 2. Not exact value is 1 and 2. It is a ratio of 1 and 2. Now, what is the coordinate of the point D then? If you use the internal section formula, so it should be something like this. If I use a different color, so 1 should be with B and 2 should be with A, if you recall. Then what is the coordinate of the point D? What we are getting is that X coordinate should be 1 into 0 plus 2 into 4 divided by 1 plus 2, comma, Y coordinate should be 1 into 3 plus 2 into 0 divided by 1 plus 2. That means what? So this implies the coordinate of the point D becomes 4 into 2, 8, 8 by 3, right? Comma, it is 3 by 3, and that is 1. So 8 by 3, comma 1. So now it is very easy to find the equation of the straight line OD, correct? What is the equation of the straight line OD, which passes through 2 points? One is origin and another one is that 8 by 3, comma 1. So how we can find the equation of the straight line OD? So equation of the straight line OD. So please do along with me, dear students. Okay, equation of the line OD is, it will be y minus y1, that is y minus 0. 1 point is 0 na. So 0 minus 1, or the other way we can write y minus y1 by y2 minus y1, that is 1 minus 0, that is equal to x minus x1, that is x minus 0, divided by x2 minus x1, that is 8 by 3 minus 0. So we can simplify further and we'll get what? 8 by 3 into 1. So this implies 8 by 3 into y is equal to x. So that implies y is equal to 3x by 8. This is the equation of one straight line. I hope it is clear, dear students. In the similar manner, we can find the coordinate of the point C as well. Okay. Now, if you look into the coordinate of the point C, so there are two ways you can find it out. It is the midpoint of DB. As you find the equation of the, as you find the coordinate of the point D, you can easily find what is that midpoint of DB, because B coordinate you know and D coordinate you know. Or the other way you can find it out is that the point C is dividing the line segment AB in the ratio of 2:1, correct or not? So if we represent that same straight line segment, this thing here, so this is the point A having coordinate 4, 0, and this is the point B having coordinate 0, 3. And where is the point C? The point C somewhere here, correct? And the division is in the ratio of 2:1, correct or not? The point C internally dividing the line segment AB in the ratio 2:1. So what is our target? Our target is to find the equation, find the coordinate of the point C. And how to find the coordinate of the point C? For that, what you need to do is that 2 should be related to the coordinates of B and 1 should be related to the coordinates of A. To know details about that internal section formula and external section formula, please go back to my relevant video lectures, which is available both in YouTube and in the online platform. So now, from here, what we can find that coordinate of the point C is something like this: that 2 into 0 plus 1 into 4 divided by 2 plus 1, comma 2 into 3 plus 1 into 0 divided by 2 plus 1. Now if we simplify further, that implies the coordinate of the point C becomes 4 by 3, comma 3 into 2 is 2 into 3 is 6, 6 by 3 is actually 2. Okay, so it is 4 by 3 comma 2. So what is the equation of the line OC then? So we can find the equation of the line OC is y minus y1, that is y minus 0, because one point is 0, divided by 2 minus 0 is equal to x minus 0 divided by 4 by 3 minus 0. Let me write 4 by 3 properly. 4 by 3 minus 0. So from here what we get, dear students? From here what we get is that 4 into y by 3 is equal to 2 into x. So this implies y is equal to 3x by 2. And this is the equation of the another straight line. I hope it is absolutely clear, dear students, that you understood that both the equation of the straight lines. Okay. Now, as we understood this thing, the next point what we are going to discuss is called the symmetric form or parametric form or distance form of equation of a straight line. Very important point, and I'll show you some representative examples, and it will help you to understand why it is so important. This kind of equation is very important. So let me first describe what is the what is meant by symmetric or parametric or distance form, and I'll explain you in each of these cases why it is so. So dear students, here what is that the symmetric or parametric form. So in under what situation this symmetric and parametric form is coming into the picture. Suppose the equation of a straight line passing through a point x1 comma y1 and makes an angle theta with the positive direction of x-axis. We know what is that. Okay, so let's first describe this problem. So let me first draw the coordinate axis, dear students. So these are the coordinate axis. So this is x-axis, this is y-axis, this is origin. Now suppose we have a straight line which passing through a fixed point x1 comma y1 and makes an angle theta with the positive direction of x-axis. So let's first draw the straight line in blue color. Suppose this is one such straight line. Okay, so suppose this is a straight line L which passing through a fixed point. So let me show the point here is that suppose this is the point. It is passing through a fixed point x1 comma y1 and it makes an angle theta with the positive direction of x-axis. Then what is the equation of this straight line? Equation of this straight line is that y minus y1 is equal to m is nothing but tan theta into x minus x1, correct now? So now we are just representing it in the little different form. Tan theta is equal to what? Sin theta by cos theta. So from here we can write y minus y1 is equal to sin theta divided by cos theta into x minus x1. So this implies what, dear students? That from here what we can write is that x minus x1 divided by cos theta is equal to y minus y1 divided by sin theta. Correct, no? Now that we can assume this is equal to r. Say, what is r? I will come in another few minutes. If you consider that x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r, then what we are going to get? We are going to get x is equal to x1 plus r cos theta. And what we are going to get? Y? Y is equal to y1 plus r sin theta. That means what? Any arbitrary point on that straight line. What is xy? Xy is nothing but any arbitrary point. It could be here, it could be here, it could be here, it could be here, any point on this straight line. But what its generic coordinate? Its generic coordinate is x1 plus r cos theta, comma y1 plus r sin theta. Suppose we get a point here. Suppose this is a point called Q. What will be its coordinate? You know, generic one. It is x1 plus r cos theta, comma, if I can move it little right hand side, the digital board. So it is y1 plus r sin theta. If you see, dear students, that in this coordinate, that x1 plus r cos theta and y1 plus r sin theta, you know, theta, x1, y1 are fixed. So what is varying? The varying thing is r. And you know, dear students, what is r? R is the distance between the points P and Q. You find the value of PQ, that will get the value is r. Correct, no? So let me show you by means of an very representative example. So here, so what is the coordinate of the point P? Coordinate of the point P, we get it as x1 comma y1. And what is the coordinate of the point Q? An arbitrary point. We get x1 plus r cos theta and y1 plus r sin theta. Correct? So now, as we know the coordinates of these 2 points, we can find the distance between them. So this implies, what is PQ? PQ is equal to square root of the difference of their x coordinates. Correct, no? So x1 plus r cos theta minus x1 complete whole square plus y1 plus r sin theta minus y1 complete whole square. So from here, what we get, dear students? So from here, what we get is that PQ is equal to square root of r square cos square theta plus r square sin square theta, because x1 get cancelled, y1 get cancelled. So r square cos square theta plus sin square theta, cos square theta plus sin square theta. So from here, what we get, the value of PQ is equal to r, as that's what I was telling, that r is nothing but the distance between the points P and Q. So dear students, as you vary r, you will get different points on that straight line L, which is at a distance r from the point P. And that is why this is also known as the distance form, as I started saying in the beginning. Distance form. Why it is a parametric form? Parametric form is that you can represent the coordinate of any point on that straight line by means of a parameter called theta. Why theta is a parameter? Why x1, y1, r is not a parameter? Because if you see how you describe the point Q is something like this. No? That is the generic point on a straight line. Correct? That is the generic point on a straight line Q. If you look into the different components of the coordinates of the point Q, you will see that x1 is a constant, it cannot be a parameter. Y1 is a constant, it cannot be a parameter. Theta is also a constant, it cannot be a parameter. Why x1, y1 and theta are constant? Because that is the fundamental of the of our discussion, that the straight line passing through the fixed point x1, y1 and makes a fixed angle theta with the positive direction of the x-axis. So x1, y1 and theta are constant. Then what is varying? It is r is varying. And dear students, what is varying? That is we known as a parameter. And later we will see when we will discuss about the circle, parabola, ellipse, hyperbola, you will see that how parametric, form of equation, or a parametric point makes a lot of sense. Why it makes a lot of sense? We can say it now also. To represent a point on that straight line, we need only one unknown, that is the parameter that is called theta. Apart from that, everything is known to us. And we always like to represent something with less number of unknowns, isn't it, dear students? Anything, if we can represent that thing with the less number of unknowns, then it is more meaningful. So here also, if you see the coordinate of any point on this straight line is represented by only one parameter, that is called theta. But whereas in the whatever we have discussed so far, you always take a point, let's alpha comma beta be an arbitrary point on the straight line. So you have two unknowns, alpha and beta. But here we are representing a point on that straight line as a x1 plus r cos theta comma y1 plus r sin theta, only one parameter, that is theta. That is so it is preferable. So that is why it is also known as a parametric form. And why it is symmetric form, dear students? Because we write in the symmetric manner, x minus x1 by cos theta is equal to y minus y1 by sin theta. That is why it is, known as a symmetric form. This kind of equation, that symmetric form. So what we represent here is that if we represent that, point slope form equation in a different manner, in a symmetric manner. What we did, it was the original equation, no, dear students. So this we all are aware of. Y minus y1 is equal to m into x minus x1, we are aware of. From there, what we did is that we make a symmetric form, that is x minus x1 by cos theta is equal to y minus y1 by sin theta is equal to r. We made a symmetric form. That's it. Why it is important? In the question, whenever you get questions related to the distance from a fixed point on a straight line, application of symmetric form or parametric form or distance form are of prime importance. Okay. Now, the point is that, there is a very interesting point I also want to say, and I thought that you may also ask this question. When I say that, if p x1 comma y1 is a fixed point and we get a point q which is at a distance r, but r could be the either side of the state point p. Now, here we get q, we can get q here also, which is at a distance r. Suppose this is the point q dash. Possible? So what we see, the point p having coordinate x1 comma y1, point q which is at a distance r from the point p having coordinate x1 plus r cos theta and y1 plus r sin theta. But it may also possible na, that if r is the distance, we can get another point q dash, okay, such that, pq is equal to, what we can write is that pq is equal to pq dash. That is also equal to r, na. So what will be its coordinate? Its coordinate cannot be exactly like q, na. Then we know from the fundamental point of coordinate geometry, two different points cannot have the same coordinate. So what will be its coordinate, dear students? Its coordinate will be x1 minus r cos theta, comma y1 minus r sin theta. Got it? So, dear students, what we understood is that, that this kind of equation, that is the parametric form, is very useful for the cases where we need to deal with the length of any portion of a straight line. Okay, at a given point, at a given distance r from the point x1 comma y1 on the line, that is in the symmetric form, x minus x1 by cos theta is equal to y1 minus y1 by sin theta. There are 2 points. One is x1 plus r cos theta, comma y1 plus r sin theta, and another point is that x1 minus r cos theta, comma y1 minus r sin theta respectively. Okay, let me, whatever I just said, let me write it down here. from the class note. After that, we will solve a problem together. Okay. So please go through the statement. It is self-explanatory, and I just read it out a few seconds back. Okay, dear students, now let's solve a problem together. Okay, you please open your notebook, do along with me, and if you have any smallest clarification, smallest doubt, never hesitate to let me know about it. Okay, and here is the question is in front of you. Let me increase the font so that you can read it properly. So, dear students, the question here is that a straight line is drawn through a point 2, 3 and is inclined at an angle 30 degree with the x-axis. With the x-axis means if nothing is mentioned, with the positive direction of x-axis. Okay. Find the coordinates of 2 points on it. Find the coordinates of 2 points on it at a distance r. At a distance 4 from the point P on either side of P. Let's make a visual representation of this problem first. Okay, coordinate geometry, visual representation makes a lot of sense, dear students. Okay, so if we make a visual representation of this problem, so first let's draw the coordinate axis. So this is x-axis, this is y-axis. At any point of time, dear students, any smallest doubt, never hesitate to ask me. So the point is that 2, 3. 2, 3 is a point something like this. Suppose this is the point P, 2, 3. And it makes an angle 30 degree with the x-axis. So let me draw the straight line in a different color. So this is a kind of a 30 degree, you can assume, right? So this is our straight line L. Now we need to find okay. So let me put this thing, yeah. So this is our equation, this is our straight line L. Now we need to find the coordinates of 2 points on it at a distance 4 from the point P on either side of the P. That means what? Suppose we get a point Q here, which is at a distance 4 from the point P, and another point Q dash here, which is at a distance 4 from the point P. So that means what? PQ is equal to PQ dash. So what is our task? What is our task is to find the coordinates of Q and Q dash. That we need to find. And what is the angle made by this straight line, dear students? That angle made by the straight lines with the positive direction of x-axis is 30 degree as according to the question. So what we are going to get out of it? So what we are going to get is that something like this. That what is the symmetric form of this equation? It is x minus x1. x1 is the x coordinate of the point P divided by cos theta, that is cos 30 degree. Theta is 30 degree, is equal to y minus y1, that is the y coordinate of the point P, that is 3, divided by sine 30 degree, that is equal to r. Though frankly speaking, this symmetric form representation was also not that important. One thing we are sure, that coordinate of the point Q is that, as we just discussed, x1 plus r cos theta. That means 2 plus r is 4. Here r is 4 now. Okay, r into cos 30 degree, and y plus r sin theta. Y is what? 3 plus 4 into sin 30 degree. So this implies what? Let's find the coordinate of the point Q. So this implies what? This implies q is equal to q. It is 2 plus 4 into cos 30. Cos 30 is equal to root 3 by 2. Correct? Comma 3 plus 4 into sine 30. That is equal to 1 by 2. So from here we get the coordinate of the point q as 2 plus 2 into root 3, comma 3 plus 2, that is 5. Correct? Now let's find the coordinate of the point q dash. Okay, so now the coordinate of the point q dash, let me use a different color. So coordinate of the point q dash should be something like this. It is 2 minus 4 cos 30 degree. Correct, dear students? And 2 minus, sorry, not 2 minus, 3 minus 4 sine 30 degree. Symmetric form. So this implies q dash is nothing but 2 minus 4 into root 3 by 2, comma 3 minus 4 into 1 by 2. So from here what we get? From here we get q dash is equal to 2 minus 2 root 3, and 3 minus 4 means 4 by 2, that means 3 minus 2, that is equal to 1. So we get two coordinates. One is that q dash, which is 2 minus 2 root 3 comma 1, and another one is that 2 plus root 3 comma 5. Both are at a distance of 5, 4 units from the point P, that is whose coordinate is 2 comma 3. Correct? So the distance between P, Q, whatever it is, the distance between P, Q dash, both are same. Correct? Got it? So what we get is that PQ is equal to PQ dash, and that is equal to 4 units. So this is the first question what we have done, dear students. I hope it is absolutely clear. Any doubt, at any smallest doubt, any point of time, please never hesitate to let me know. Now, the second question I would like to give you, and I want to give you it in the form of an assignment, which you need to solve after the class and show it to me, because I want you to think properly and then answer. So, but I would like to give you a little bit of hints to this question. So here the question is, the question here is that find the distance of the point 2, 3 from the line 2x minus 3y plus 9 equal to 0 measured along the line x minus y plus 1 equal to 0. Very good question. So let me explain you what is the real intent of this question. Find the distance of the point 2, 3 from the line 2x minus 3y plus 9 equal to 0. Suppose 2x minus 3y plus 9 equal to 0 is this one. For example, so let's assume this is 2x minus 3y plus 9 equal to 0. This is the equation of the straight line what I drawn in red. Now we have a point 2, 3. Suppose there is a point P is there 2, 3. Correct, dear students? That is the point P 2, 3. Now we need to find the distance of the point 2, 3 from this line. There are many distances, right? If no other information is given, that means it is a perpendicular distance. How many distances is possible? So this is one distance, this is one distance, this is one distance, which is a perpendicular distance. This is one distance, this is one distance. Many distances are possible. But which we need to find? We need to find measured along the line x minus y plus 1 equal to 0. Suppose we assume the straight line that x minus y plus 1 equal to 0 is something like this. What I drawn in the blue color, that is actually x minus y plus 1 equal to 0. That means parallel to this one. So our as I drawn many green color straight line, segment which is drawn from the point 2, 3 to the straight line 2x minus 3y plus 9 equal to 0. Among them, we need to find this one which is along the straight line x minus y plus 1 equal to 0. That means which is parallel to the straight line. That means if this is the point Q, we need to find the PQ. So that, what I can say is that, this straight line, that suppose we give this straight line is L2, that what we can say is that PQ, that PQ is parallel to the straight line L2. So what we need to find? We need to find a point on, the straight line 2x minus 3y plus 9 equal to 0. Okay, such that if the point is Q, then PQ is parallel to that the straight line x minus y plus 1 equal to 0. There are multiple ways you can solve this problem, and all the relevant information we have discussed in so far, whatever we have discussed on straight line, it is there. So it is a task to you to explore all these video lectures as available in the online test platform at KonarClasses.com and also available in YouTube. Go through all these video lectures, find out what is the best possible way I can find the distance PQ, and do let me know before we start our next class. In fact, I will prefer if you start working on it immediately once you complete that class and share your solution with me over WhatsApp. So with this note, I would like to conclude the class for today. And we will continue in the next class where we will be discussing the normal form and other relevant stuff. Thank you very much.